All right, it's now later, and I'm really excited to finish this up. So I think where we left off is realizing we need to call a constructor provided by the ability. So we made the make error and make success, and then everything here turned red. So let's go back and figure out what needs to happen next. Right, we're going to make an enum constructor. So this is going to be the type of the enum. So really neither success type or error type. It's actually going to be I think it's going to be okay, so we have a few types to pick from. There's result, which we know implements try with T and E. So I think that's what we want to produce. So let's start there. And we'll even log what we're making here. So producing a and we should probably put result.getType in a local because we've used that a lot of times. Okay. The variant name. So this is interesting. Oh, right. We're not doing an enum constructor at all. We need to call the ability function. That's so much better. So instead of error conster, we're going to say make error call. And the other calls, we're going to do away with fun. Make error call, get success call, success call. Okay. Actually, oh, this can't be result. We want to be calling try. Like that. What do we make error from? Ooh. Try value.get error. Wait. So is that the same thing as just returning it? Okay, we have a result TE. Yeah, we just return the result. Because pulling out the error and then putting it back in is going to be a no-op. So, if I'm right, then return error is going to be, if it is not a success, return it. So we'll make a return, which takes a, I'm just going to assume it's called typed return, and it is. Where the value is just the result, but not the result variable. So result value var, value, try value var. Ooh, we don't have its Oh, right. Variable expr. And that'll be the call span. And I think I might say that I moved this already, so we actually need a few copies of this expression. That's completely fine to do. We won't clone it the last time, though. We'll save the very final clone. You want to be box. Okay. Result doesn't exist. So let's just use it's the try type. What do we call it? Try value. Try value type. We're going to go try value original expression. That's fine. And we're going to use try value type. There. Type of a return, yeah. Oh, okay. So I was talking earlier about how this is going to get type checked and all this stuff, but it's actually not. we're just synthesizing the whole thing. So we need to say what type it is. So we can say it's a success type because we know that this branch returns, but we got to make sure we get it right. So that's fine. If expr. So let's push it. Where's the last time we did something with our result block? I thought we pushed a, yeah, we pushed a statement. Let's do it all in the same place here. We can actually push expr and it'll wrap it in a statement. So we'll push this if expression here. Okay, so else return, and what we're actually doing here is returning try value. All right, and there's some type checking missing. So we need to find out what the expected type of main is to make sure we can even do this. So we're going to call it the block return type. We're going to do up here in return, end and break. That's loop info. It's a bit different. So it's really the same. It's the return type. And it's nearest planet closure, nearest parent closure, which includes functions. So this is how returns get type checked. It would be nice to just call into this code, which we're going to do. We're going to say handle return. So we're going to factor this out. So we're going to need a calling scope, which I'm just going to call scope ID. We're going to need a span, which then we'll take funcall.span, replace with span. And we need our value. What are we returning? Returning this. Oh. Right. So this thing gets the return type before, yeah, it needs to know that before it can evaluate this. So this is really the thing that we want to factor out. Yeah, type a result because we expect it. And it's not going to be a let, it's just going to be here, and it's going to be like that. And we need a span for errors. Whoops. Okay. This eval return becomes pretty much useless, but I started it and I might as well. It might be handy later if it grows. I don't think it's that bad. We no longer have an optional here. This is where we're going to need to do a sum. So this is going to be, because these do a sum, yeah. So we'll wrap this in some. Could eval return map sum. No, we'll just do okay sum with this madness. And it's it doesn't take that anymore. The first one, calling scope and fun call span, which we're calling call span in this scope. Okay. All that so that we know the expected return type. So what will happen here is we'll issue a compiler error to the user if we're not in a returnable place, which means we're not inside a function or a closure, which I guess means we're in like doing a constant. I'm not really sure when that will happen, but point is that we're checking. Just real quick, I know it's been on the screen for a bit. So nearest parent closure does what you'd think, goes up, checks the metadata, sees is this a closure, and then otherwise we'd look for a nearest function, special function. So we can do this first actually. Up here, we're going to do the try ample. Before we even evaluate the expression, we can say return type. Let's if self dot expectability implementation block return type try ability ID. I think. And then they need to match types. later we could expand this to look for the nearest try block. So all it really needs is a block of code that has a return type of result. So this would allow you to build like this type of thing, where you do like a block, as long as you were willing to specify your expected type here, or provide the expected type in some way. This would let us build try blocks. I might throw a little to do in here. This is where we could enhance to support try blocks. Rust actually has these, and they've been experimental forever, and I think will probably never not be. But just interesting trivia. So this is the block try impl, and this is the value try impl. And then we're going to say block impl args and we're going to make sure that those match. So we could do one loop where we grab the error type and the success type. Or maybe let's just validate. So for this is going to be expected. Let's just go expact for now in block impl args header zip impl args header if let error message self.check types expected actual calling scope return failf call span this function expects a try, but with different types than the value. Message. And that's going to say expected blah, 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 blah. Let's leave that off. I don't think that's really a to-do. It's just noise. Okay, in theory, this should compile now. Well, okay, this will compile now, but will it work? Okay, it ran. So it really compiled. Here's the reload. Not done yet. Okay, so let's quit. Okay, and we have no errors. So what if we were expecting a different success type, bool? We get an error on the try. Missing ability try. Okay, that's true. And that's for our result. So let's add some color here. So that was this one. So we're gonna map error and take the thing not found, and we're going to do an erf. I kind of want to do, I've done this before, but I kind of want it like this with mute e. And I just want to be like e dot message equals format. Oh, this is the value. I think for the value it's okay. So what does it say? Missing ability try. So I want it to say, you know, expression passed to try needs to implement try. I don't. It's good enough. But for the block, because that's less immediately apparent, this is where we want to say try can only be used in a function or closure from and then the old message, if you please, and then E or ED. Okay, so reload here. Try can only be used from a function or closure that implements a type implementing try. Missing ability try implementation for bool string. Yeah. Okay. Now let's get the mismatch going. Which means just making bool error implement it. Weird, but it works. Oh, yeah, that would help, wouldn't it? Okay, and now we say this function expects a try, but with different types than the value. What I could do is put them in a result together and show the full types, but I don't know, it might not be result is the thing. It could be a totally custom thing. It doesn't even have to be a variant. Like it could be a struct that happens to have like 2 flags in it, or a struct that we can look at and know if it's a success or an error. So, but with different, there's going to be error or success. Let type equals if let's try that. But with a different success type than the value. Let's not capitalize it because it's not really the name. Or we could make that the real name. Instead of TE, we could just go success and error. No, I think TE is okay. Let's bring can fail down here. Function not found can fail. Wonder if that other one's stale. Yeah, we got into a bad state here where the errors aren't clearing. I'm not sure what's wrong with my LSP implementation, but that's a very different stream, very different session. So this should be exiting with code 42. Oh. No, yeah, well, because we don't type check main, so it's returning some... It's trying to exit with something like a... It's probably going to interpret... It's going to interpret the enum as an integer, I think. I'm just glad it's not crashing, or maybe it should be crashing. So I have a to-do for type checking main. Type check main. Main. Type check main. Let's move it up. It should probably be type checking main. But now I'm glad I didn't do that yet, because it's going to become a little bit more interesting now that it can be a result. It needs to be a result int, and then some error. We could do an error ability, or maybe something that implements show. So the type there would be, well, it can't be abstract. I can't actually write that type here, but it would be, yeah, you can put any error type here if there's an implementation for toString, essentially. Should we test this out more? Should we try? Let's make a struct that's also try-y. Oh. Oh, this is interesting. So, okay. I'm requiring that both of these implement result or implement try in the correct way, but they could be totally unrelated types. So I'm kind of like imagining I have trait objects. We don't actually know. Yeah, this will let the function return things it shouldn't. Yeah. Let me explain. Or I think I can reproduce. So I can def type foo, and that's actually a struct with, I don't know, one field called a. And I can actually implement try for my struct. For foo. So foo is a try int error. And yeah, so to make an error, I'm going to say a is true. And to make a success, I'm going to say, well, true. I'm going to say a is false. Might as well implement this. Self.a get success. And I'm just going to always return 3 because that needs to be in it. And then for get error, I'm going to always return foo error because that needs to be a string. So that checks. And now I can do this, and I can say try of foo a true, which will not work because it's just for this struct. But if I say this is actually foo, then it works. But if it fails, we're going to be returning well, this is the thing, right? We're returning the error variant. Yeah. So if it fails, we're going to return this struct. And if this one fails, we're going to return this result variant. And those are obviously not the same type and not the same size. So once we know what type it is, it's actually not enough. Any type that implements result is fine, but they have to all be the same. And this has to actually return like something that is the type the function returns. So yes, that needs to implement try, and we could even go ahead and check that they do the same types because that's going to be better, but then we need to actually just like say, hey, is it even okay for me to return this? So that would be down here, I think, and this would say if let error. This is a type check of the block return type and the try value type. Both the success and the failure. Oh, this is more complicated than I thought. So my issue here is if the success types are different, what I'm about to do will fail as well, but I'm not trying to return the success. It's only the error type that has to be the same. So maybe this is why the Rust trait is so complicated. Oh, that's exactly why. So maybe instead of that, we do call make error. We call make error on the actual return type using the error this thing gives us. So instead of our failure case just returning the value, so here this would fix it. So I'm not going to return this. I'm going to return, you know when I said that calling try make error from value.get error was just a no-op? Well, it's not a no-op because this could be a struct foo, and this could be like a result variant. They could be totally unrelated types. They just share an error type. So we need to make the thing we're actually returning yeah. So try make error, and then I need a way of saying which try, which impl. I don't have a syntax for like Rust's Turbofish. I don't have a syntax for, you know, but essentially I want this make error, not foo's make error. Well, I guess I can find one because I can solve for where, based on the expected type. I may be able to do it this way. So by hinting that this needs to be a result int error, I think the code might work. But I can actually test it out by writing out the block. Like uncommenting this. Whoops. So we'll just go try value, remove all these. So can fail int. Okay, wait a minute. Yeah, different success type, same error type. That's what matters. So I want to call can fail bool, which should give me a bool. Now maybe I want to just do this. So here's my try value. I'm going to call this. Let's make sure things are, yep, still working. And with true, it's a success. So then that's going to be get success. Which should be an int. Yeah, it should be 3. So we can assert that result is 3 after this. That's not really what matters. What matters, I mean, this is checking. What if I don't supply this? Still checks. How does it know which copy of make error? Yeah, look, LLVM. LLVM is telling us that we yeah, we're returning the wrong type. So I knew something was up. Oh, no. I'm gonna do a block here. So that I can say E. And that should be, so for foo, it's string. Which it is. Then we can say the actual error, or the actual failure. Let's try make error from E. Failed to resolve. Yeah, this is what I wanted. So we're getting 4 copies. So let's go back to maybe just having 1 copy. Yeah. It says what type is self. So if we go to make error, it's like make error. The return type is the only way I know who you're talking about. So what gives? So what I can actually do is say, well, failure needs to be result int error, the exact type that I'm returning. Even though the int can't possibly appear, we need to return the same type that the function says it returns, because it has to be like the same size and everything. So that actually works. And then we can return failure. And well, I'm still not happy. But that's because, we've said that main returns an int, I think. Ret I8. Yeah, we're returning an enum. And I don't know if I'm going to be able to get to where I declare main. But oh, well, I'm still running my broken version, right? So what if I only do this one? Well, this one I know is in error. It's the bool one that's a problem, except for the one I've handwritten. Does this make LLVM mad? It doesn't. Okay. So this approach works. And it doesn't mean, I think we're okay. I think we still check the value. Okay, yeah. The value success type doesn't matter because we're not returning it. It's only the error type. So we're overchecking here. So I could check if the name is error, or I could just rely on the ordering. It's T then E. And I'm not going to change it. So let's just do that. Well, let me just grab the expected error. I'm doing this. Error type from the value impl. Value impl args. I need value success type. Yes. That's fine. So let's do block error type. Even though it's going to be 4 lines, this is nicer. We'll find E. And then we're just going to do this. We don't need this anymore. And now what we need to do is we do need to get error make error. And now I understand this operator so much better. Okay. Ooh, 42 minutes. Yeah, let's take a quick break. Make this a trilogy.